All right, let's talk about absolute value graphs. Now, they can look a little tricky, right? But what if I told you to think of them less like a math problem and more like a secret code? A code that, once you figure it out, lets you twist and turn this simple V-shape into pretty much anything you can imagine.
So, that's the million-dollar question, isn't it? How in the world do you get from this one basic V-shape to all these other crazy versions? Ones that are shifted around, stretched out, even flipped completely upside down? Well, that's exactly the code we're going to crack together.
So check this out. Over on the left, you've got our home base, that simple, perfect V. And on the right, that's where we're headed. Every single one of those graphs started out as that basic V, and then got a simple set of instructions. And by the time we're done here, you'll know exactly how to write those instructions yourself. Okay, first things first. Before we can start messing with things and transforming them, we really have to get to know our starting point, our foundation. We're talking about the original V-shape, what we call the parent function.
So let's back up for a second. What even is an absolute value? It's really just how far a number is from 0. That's it. Think about it. How far is 5 from 0? It's 5 steps. Okay, but how far is negative 5 from 0? It's also 5 steps. See? You can't have a negative distance. And that's the secret to the V-shape. The graph can never dip below the x-axis because as soon as those x values go negative, the absolute value makes them positive again, perfectly mirroring the other side.
And here she is in all her glory, the parent function. F of x equals the absolute value of x. See that point right at the bottom, where the whole thing pivots? That's called the vertex. And for our original parent function, that vertex is sitting nice and tidy right at the origin, 0, 0.
I absolutely love this little memory trick from the source material. If you ever have a brain freeze and can't remember the shape, just picture the absolute coolest guitar out there, the Gibson Flying V. It's kind of goofy, but trust me, it works.
Okay, cool. We've got our basic V-shape down cold. Now for the fun part. It's time to pull back the curtain and reveal the secret code that tells us how to move it, flip it, and stretch it all over the place. Let's meet the vertex form.
This right here, this is the whole shebang. This is the master formula. Every single change we could possibly want to make is controlled by one of those 3 letters, A, H, and K. Just think of them as the knobs and levers on our graph-making machine. So let's see what each one does. We're going to start with the easiest part of the code, H and K. These two have one job, and one job only. They tell the vertex of our V-shape where to go. They control its location on the graph. That's it. Let's start with K. That's the number that's just hanging out outside the absolute value bars. So for absolute x plus 3, our K is a positive 3. And the instruction is super simple. Just take the whole graph and slide it up 3 spots. And look, that's exactly what happened. The vertex went from 0, 0 right up to 0, 3.
Now let's look at H, the number that's inside the absolute value bars with the x. Here we've got y equals x minus 2. This little guy controls the side-to-side movement. So you can see the vertex moved from 0, 0 over to 2, 0. But hold on a second. The equation says minus 2, but the graph moved to the right in the positive direction. What's up with that? And this right here is the #1 spot where people get tripped up. So lean in for this one. The vertical shift K, it does exactly what you think it's going to do. Plus 3, it goes up 3. Easy. But that horizontal shift H inside the bars, it's a little trickster. It does the exact opposite of what your brain tells you. X minus 2, you'd think that goes left, right? Nope, it moves to the right. And x plus 2 would move it left. Just burn this into your brain. Inside is opposite. Outside is obvious. So here's the bottom line. H and K work together to give you the exact coordinates of your new vertex. In the form x minus h plus k, the vertex is just sitting there at the point hk. This becomes the new anchor point for your entire graph.
All right, we've totally mastered moving the graph round. Now let's get to the final piece of our code, that A value. This is the number multiplied out front, and it's in charge of 2 really cool things, the V's shape and which direction it opens. This little table really breaks it down nicely. A has 3 jobs. Job 1, if A is negative, bam, it flips the whole graph upside down. Job 2, if the size of A is bigger than 1, like 2 or 5 or 10, it gives the graph a vertical stretch, making the V much narrower. In job 3, if A is a little fraction between 0 and 1, like a half, it squishes or compresses the graph, making it much wider. And here's what that actually looks like. On the left, A is 2. See how skinny and steep that V is? That's the vertical stretch. On the right,
A is 0.5, or 1/2, and the graph looks wider, more relaxed. That's the vertical compression. It's a pretty dramatic difference, right? And this is what happens when A goes negative. The whole graph just does a somersault over the x-axis. It's the same exact shape as the original, but instead of opening up to the sky, it opens down to the ground. That negative sign is your signal to flip it.
Okay, quick public service announcement. This is super important. It's really easy to look at this shape and think it's a parabola, that U-shape you get from quadratics. It is not. A parabola has a curve. An absolute value graph is made of two perfectly straight lines that meet at a sharp point, the vertex. No curves allowed.
All right, deep breath. It is time. We have decoded A, H, and K. Now let's put our new superpowers to the test and graph a function from scratch just by reading the code. No boring table of values needed.
Let's break down g of x equals -2 times the absolute value of x minus 1 plus 3. Looks like a monster, but it's not. Step 1. Find the vertex. We just grab our h and k. The vertex is at 1, 3. Done. Step 2. Check A. It's -2. That negative sign screams at us. This thing opens downward. Got it. Step 3. Look at the size of A. It's 2, which is bigger than 1, so we're looking at a vertical stretch. It's going to be a skinny V. And finally, step 4. Let's draw it. We put a dot at our vertex, 1, 3. Then we use that A value, the -2, kind of like a slope. From the vertex, we go down 2 and over 1 to the right. There's our next point. And because it's a mirror image, we just reflect that point to the other side. Boom.
And there it is, the finished product. You can see it clear as day. The vertex is at 1, 3, it's opening downward, and it's definitely narrower than the original. We didn't have to guess or plot a ton of points. We just had to read the story that A, H, and K were telling us.
So, let's do a super quick recap of the essentials. Everything starts from that basic parent function y equals absolute value of x. The master code is the vertex form y equals a x minus h plus k. H and k move your vertex around the map, and a is the fun one that flips, stretches, and squishes the shape. And that's really the entire code right there.
Now that you've totally cracked this code for absolute values, I want to leave you with one last thought. This HK system, this isn't some one-off trick that only works for V-shapes. This is like a master key in the world of graphing. So the next time you run into a parabola, or maybe some other kind of function, take a closer look. You might just find a very familiar code hiding in plain sight, just waiting for you to crack it.